Hey everyone, let's take a look at number 14 in section 4.2. We're going to find the minimum and maximum values of this function here, this rational function, on the interval from 1 to 7. Again, your function might be slightly different and your interval might be different as well. We're going to do this, of course, by comparing the values of this function at the critical points and the endpoints, or any critical points. Make sure the critical points, of course, are on the given interval. Our endpoints are 1 and 7. We now need to find the critical points. You might just note that the denominator here for this rational function, which is x squared plus 3x, factors, right? Factoring out an x. And you can see from this that the domain of this function is all real values of x, such that x is not equal to 0 or what, -3. Those would make the expression undefined. In fact, the function, if we were to graph it, has vertical asymptotes at these values. Notice our interval from 1 to 7 excludes these values, okay? And that's important because the technique we're going to use, or we're only guaranteed, I guess, to have a maximum minimum on a closed interval for a function if it is continuous on that interval. And so if these values were included, we would not be continuous and we wouldn't be able to compute the max or min necessarily. So good thing though, we're not going to be bothered by these vertical asymptotes. Okay, so let's find the critical points on this interval. So let's just find the critical points. That's, of course, the values of the variable x, so that our derivative of this function is either 0 or undefined. In the domain, of course, we're excluding 0 and -3 in that. So I'm going to just use the quotient rule on this. I take the derivative of the top function, derivative of x minus 1 is 1, times the bottom function minus the top function, and the derivative of the bottom would be 2x plus 3. All that will be over the bottom function squared. Now I'm going to distribute the 1 through. Of course, that just gives me the x squared plus 3x. Here I'm going to go ahead and FOIL this thing out first before distributing the 1. So x times 2x gives me 2x squared. The outer is 3x. The inner is -2x. 3x minus 2x is 1x. And the last -1 times 3 is -3. Now be careful because I need to distribute this negative through, so it becomes -2x minus x plus 3. Combining like terms, x squared minus 2x squared is -x squared. I've got 3x minus x is 2x, and then I've got my last 3. And so all this is still over x squared plus 3x squared. So the question is, when is this thing 0 or undefined? We know it's still undefined when x is 0 or -3, but of course those are not values in the domain of the function, so those are not critical points. Excuse me. When is it 0? Well, it's going to be 0 when the numerator is 0 and the denominator is not 0. So let's find out when the numerator is 0. I'm going to factor out a -1 to make it easier to factor, which just basically changes the sign of these other terms. And then how does this factor x squared minus 2x minus 3? Well, it factors as x minus 3 times x plus 1. Hopefully you can do that fairly easily. And so that tells me that the critical points are what? This is going to be x plus 1 will be 0 when what? X is -1, and x minus 3 will be 0 when x is 3. Those are the critical points. Just plugging those values in gives me 0 divided by some number. But notice only x equal 3 is in our interval. Our interval was, again, remember, 1 to 7. And so -1 would not be something you would want to check. So be real careful. If you're checking the value of function at critical points outside the interval, you could get an incorrect result. So the directions say, of course, check the values, comparing values of the original function. We're not checking the value of the derivative, right? Value of the function at our critical points that are in this interval and the endpoints. So I'm going to check at the endpoints 1 and 7 and at our one critical point in this interval 3. So if I plug in 1 into my function y, what do I get? Well, 1 minus 1 is 0. Bottom I get 1 plus 4. 0 divided by 4 is 0. When I plug in 7, I'll get 7 minus 1 is 6. 7 squared is 49. 3 times 7 is 21. And that will give me 6 over 70, which I can divide top and bottom by 2, 3/35. I can approximate that with the calculator just for reference. And then I plug in 3. So up top, I will have 3 minus 1 is 2, 3 squared plus 3 times 3, 9 plus 9. I get 2/18, which is 1/9, which is approximately this. So for reference, I can now check which is the smallest. Well, obviously 0 is the smallest. That's my minimum. Which is the biggest? Well, 1/9 is the biggest. And they do want to give the exact value. Some of you know how to use your calculators to get the max and min, these decimal equivalents. That's fine, but you do have to give the exact value, fraction form, using math notation, right? That'll be true on the test as well. And that's it. If you want to double check this, you could graph this function here, right? On this interval, open up your window from x equal 1 to 7. Your y value, you should, be at least 0 for the lowest number and at least 0.111 or 1/9. You'll probably just go up to 0.5 or something so you can see it clearly in your viewing window. At any rate, I hope this is helpful.